Hello everyone, this is Mr. Appel, and today we're going to talk about prisms. We're going to learn what a prism is and how to do some fun stuff with them. So let's get started. To start with, let's figure out what a prism actually is. So this is a kind of a wordy definition, but I'll try to give you some visuals to help. A prism is a polyhedron. Polyhedron is just a many-sided figure, a figure made up of a bunch of polygons. Could be 3-sided, 4-sided, 10-sided, whatever. But a prism specifically has two congruent parallel bases. Two congruent parallel bases. That's really the key to what makes a prism a prism. So I'm going to show you an example here of a triangular prism. Okay, a triangular prism has these two congruent triangles. You see triangle ABC and then A1, B1, C1. And what we've done is we connect the vertices. You connect A to A1, B to B1, and C to C1. And what that does is it makes these rectangular faces, this blue one, this green one, and then the one that's in the front that you can't really see. And this is those are all rectangles in the example that I'm showing you. And notice that if I move that triangle up, they just become kind of longer rectangles. If I move it down, they become shorter, fatter rectangles. And notice I can actually slide it over so it's skewed, and those faces, otherwise known as lateral faces, are no longer rectangles. They're actually now parallelograms. So this is still considered a prism, although we don't usually deal with prisms like that. The prisms we deal with are called right prisms, where those two faces are directly on top of each other. So those lateral edges, like this one here, those lateral edges are perpendicular. So they all make right angles, which makes those rectangles. So right prisms are the kind we're going to generally deal with. And again, those are made up of congruent bases. Those two triangles are the congruent bases. And then connecting the corresponding vertices. So that's a prism. And again, in my example, you're seeing a triangular prism, but there are other kinds. Right? You can have a rectangular prism like this one. And that one, really depending on how you orient it, any of the two faces could be the bases, because the opposite sides in that figure are all congruent. You've got a cube. You're probably familiar with a cube, and that's actually a square prism, right? A square prism where all the faces are squares, kind of a special case, but it is a prism. Then you see here a pentagonal prism. You see the top and bottom, those two bases that the vocab will use, the two bases are pentagons, congruent pentagons, but the faces are always going to be rectangles. Here we have a hexagonal prism, again, hexagon bases, but rectangles around the faces. So that's a prism. You may have done this in middle school, but looking at what a prism looks like if you unfold it helps to see how we can calculate the area, the total area, the surface area. And we use those words interchangeably, total area and surface area, or you might even say total surface area. Any of those are the same way of saying the same thing. The way I like to think of it is if you were going to wrap that prism up and give it to Mr. Appel for his birthday, or just any day because you felt like giving him a lovely gift, how much paper would you use? How much wrapping paper would you use? That's total area or surface area. And the way we're going to calculate that, and this is not a formula you'll have to memorize, you will be given these, but just so you know what it is, we find the lateral area, in other words, the area of all those rectangular faces, and then we find the area of the two bases, and then we add them together. So just the lateral area can be found by finding just the perimeter of the base. The perimeter of the base, if you look at this base, you see it's that side, whoops, that side, that side, that side, and that side. And when you unwrap it, you notice that those four sides multiplied by the height actually give you this rectangle in here that I'm botching up here, that I'm coloring all over. That actually makes one big rectangle. And so we're finding the area of that one big rectangle. And that's the lateral area. Again, all those faces, those in this case 4 rectangles, but there could be more or less, All of those rectangles put together make up the lateral faces. That's the lateral area. But all you need to know is it's the perimeter times the height, the perimeter of the base times the height. And then we're going to add the area of those two congruent figures, the top and bottom bases. And this capital B there represents the area of one of those bases. So in this example, that's a rectangle, so you would just do base times height. And this will make a lot more sense when we look at an example. So let's get to that. But first, let's talk about volume. So volume is a little different than surface area. Volume, let's think about if you were going to fill that box up, fill up that prism with water, how much water would it take to fill it? That's what a prism, what the volume of a prism is. And we can calculate that in a prism, no matter what the prism is, by just calculating the area of the base. And you see that's just represented by a capital B. That's common for that. The area of the base multiplied by the height. Okay, let's look at an example, and I think if anything's confusing, we'll clear that right up here. So here's an example. This is a triangular prism. In fact, it's a right triangular prism because it's a right triangle. A right triangle. Okay, so let's see what we do with this. Of course, you should pause and copy this down and maybe even try it yourself using those formulas, but now I'm going to do it with you. Okay, so the lateral area is the area of the, in this case, 3 rectangles, right? That rectangle there, this rectangle there, and then the one in the front. And the formula for lateral area was just perimeter of the base times the height. Well, what is the perimeter of the base? Well, the perimeter of the base is just the distance around this triangle, 3 plus 4 plus, what's that third side? Well, in some cases, you'd be stuck. But because it's a right triangle, you can use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. And of course, you recognize that as a 3, 4, 5 triangle. So you can actually calculate the length of that third side. So the perimeter of that triangle is 12 centimeters. And the height of the prism is this distance here, that's 6 centimeters. And so our lateral area, again, that's just the lateral area, the area of those rectangles, the area of those faces, is 72 square centimeters. Then, to find the total area, or the total surface area, we're going to do the lateral area plus the area of the bases times 2, because there's 2 of them, the top base and the bottom base. And they're congruent, so we just take one of them and multiply it by 2. Okay, well, the lateral area we already figured out. That's 72 square centimeters. And then what's the area of the base? Well, in this case, it's area of this triangle. And you may remember that since it's a right triangle, we can use the 2 legs as the base and the height. That's a special case. I'm not trying to trick you here. So 3 times 4 is 12. Half of 12 is 6. So the area of the base is 6 centimeters. But there's 2 of them, so we have to multiply by 2. So that's 72 plus 12, which is 84 square centimeters. Okay, now let's find the volume. Okay, volume is the area of the base times the height. The area of the base we just calculated, change colors so don't get confused, that's right over here. That's just the area of that triangular base. And the area of that triangle is 1/2 base times height, which again is 6 centimeters. 6 square centimeters, sorry, I should have said square centimeters there too, right? That's the units. And times the height, which is 6 centimeters. And so that gives us 36. Oops, that's horrible. Let's try that again. That's going to give us 36, sorry, I'm struggling with my pen here, 36 centimeters cubed for the volume. And that is how you find lateral area, total surface area, and volume of a prism. And that's all for today. Thanks.